So back in our course start geometry, I'm displaying the copy to point, so I'm not seeing the rising animation. And what we want to create now is a Plexus effect. Basically, we just need to extract the edge of our icosahedron, and probably the quickest way to do it is with a curve node, where you can extract the edge of your geometry. Then, of course, you will need to duplicate the opening animation because this is a static geometry right now, but I want to do it in a fancier way. I want to actually create geometry starting from the already animated points, and we can do it with a point wrangle. So let's drop down a point wrangle. Let's call it Plexus. Now, to create the geometry we need, like before, we use the addPrim function, and as you remember, we need two point number. One will be the current point number, so at ptnum, but we need the other point. To get the other point, before we used the nearPoint function, the singular version of it, because we needed just one point. Now we need 3 points for each point of our geometry, so we're going to use this nearPoints function. It's the same purpose as the other one, but it outputs an array, meaning a list of values. We will use this variant here, where we can define the maximum point numbers because we just need 3. And we also need a distance. We won't use it, but as you can see, it doesn't have a version with only the max point option. So we will use this one. So we need the distance and we need the max point. Let's start by creating those parameters. So let's create a float parameter, call it distance, and it will be equal to a float channel. So chf distance and semicolon. For the max point, it will be an integer one. So int max pt, it will be equal to an integer channel. So chi, we will call this max pt and semicolon. Now we need a variable to store the nearPoints function. As you can see, it's an array one, so the type will also be integer. And to create an array variable, we need to type int for the type, the name of the array, we will call it near, then space and square brackets. So now we can use the nearPoints function, and it will take the geometry index, so 0, the coordinates we want to start to look from, so at p, then we want to use the distance and the max pt. Now let's click here to create the spare parameter. For the distance, let's type something very high, like 50, and we said we want 3 points for each point on our geometry. Now let's store this variable inside an attribute so we can see it in the geometry spreadsheet. So I for the type of attribute, then square brackets, the @ symbol, and the name of the attribute to create. It will store the near array we just created. And as you can see, for each point on our geometry, we have an array with 3 point number. Now we want to create a line for each of this point number we get here, so we want to do it 3 times. Basically, we want to create another loop inside a point wrangle, which is already running on each point. We could use the addPrim function 3 times, but it's more elegant to use a for each loop. So to create the for loop, let's type for brackets, then we need the statement, meaning the initial counter, it will be 0, so int I is equal to 0. For the condition, we want this to run as many times as the points in the array are, so we can type until I is less than the length of our near array. Since we are starting to count from 0, it will count the iteration 0, 1, and 2. Then it will become 3 and it will stop. And for the increment is just I++, because we are going to integer value 0, 1, and then 2. Then we want this curly bracket to execute the condition, and we want to close it at the end of the loop. Now inside the loop we want to execute that addPrim function. So let's create a new variable. We will call it newPrim to store that new primitive we are going to create. And the function is addPrim. As you may remember, it is the geometry index, which is 0. The type will be polyline, because we need just the lines for it. Then the starting point, which is at ptnum. For the connecting point will be the point number inside the array near, and the index of that value will be the current I value, so it will be the near array with I for the index. Then we can close the brackets of the addPrim function and semicolon. Now we are getting the lines, but there's something wrong, as you may see, and you may already notice something wrong in the geometry spreadsheet before, because if we look at the point numbers, let's say for point number 0, the first value of the near array is that point number itself. That is because the near points function also includes itself as a near point. But luckily for us, there's another function, it's called remove index, which we can use to remove a certain value from an array. So after the near variable, let's use remove index, and we want to remove from the near array the first value, so 0, because always start to come from 0. Immediately we got rid of that value, but now we have just 2 points. So we could say 4 points here, but what I prefer to do is to actually increase the counter here inside the code. So let's say you made an HDA with this setup, you can expose this parameter and it will be actually the max point value. And if we go back to the scene view, we have the correct lines we need. Or I should say it may look what we need, but let's middle click on the opening animation. We had 20 points and nothing more. Here we still have 20 points, but we have more polygons and vertices than what we need, because what's happening right now is that each point is generating 3 edges. So let's say point number 50, it generates an edge from 50 to 90, but also point 90 is generating a line from 90 to 50. So we have basically 2 lines here, and we need to get rid of that geometry. So first we want to take a carve node, because we want to carve a little bit both the start and the end of our lines. So let's say 0.05 and 0.95. And as you can see, those double polygons now are generating also double points. Now we want to drop down a fuse node. This will take care of the points, but again, if you middle click, we still have too many polygons. So now we want to take a clean node, and in here we want to say fix overlaps. That will immediately delete everything, but we want to uncheck delete overlaps pair. Now, if we middle click, we have the correct amount of polygons, which is 30. And also the amount of points is correct. Before we had 20, now it's 60, because we basically split a single point into 3 by carving out the single edges. Now let's merge it with the core, so we can lay down a merge a null node. We can call it out Plexus. And of course this will be up there, and this is on the ground because the transform node is only on the left. So we want to right click on this node and say create reference copy. This will create a copy of the node with all the parameters referenced to the node. We can plug it after the clean, so now they match up, and we can merge it together to see what we have. Let's hide the point number, also the points. So we do have our Plexus effect, it's also animated. The last touch I want to add to it is some little bending effect during the animation. So let's unmerge those nodes, and maybe I can go outside, enabling by here, so we can have the display flag on the Plexus, and we can show or ghost also the core. Now to create that bending effect, we want to use a for each primitive loop. This is basically a SOP level version of the for loop you use during coding. And we want to iterate for each primitive, so it's already set up good as it is. Now on each primitive we want to resample the line. So let's say we want to set a maximum segment value of 50. Also visualize the points so we can see it. Now we want to take a point VOP and dive inside. In here we want to use a displace along normal, so connect the position and the incoming normal. And for the amount we actually want to use the curve view attribute we used before, but we have to enable from here, so let's enable the curve view. Now back in the point warp we can use that attribute with a bind node. It was called curve view, and we can feed it inside a ramp parameter. This will be a spline ramp, so change the type. And let's also put a fit range so we can control the destination minimum and maximum, so promote those values. This will be the amount of displacement. So let's plug the outgoing position in the global position and go outside. So back outside, if we change the ramp, there's nothing happening. There's something wrong maybe with our normals. Yeah, we lost our normals at some point. Let's see. Here we still have it. Yeah, we lost our normals on the fuse node. We need to unselect these recompute affected normals. So we still have the normals before the for loop. Now go back on the copy to points and also reset the cache at the start of the loop. So now we do have our deformation. So let's hide those normal, and for the ramp we just want a single point in the middle all the way up to 1. Let's put it right in the middle, and we want to change the type of all points to B-spline, so it will be smoother. And for the maximum bending I would say 0.5 would be enough. Now let's display the geometry without ghosting, and I actually want to subtract a little value. It's too much on the border right now, so back in the point warp, let's just make some room. We want to take a little subtraction before the amount value, and we want to promote this parameter, so it can be some light value, let's say 0.06 will be fine, I guess. So let's see the final loop, reset the cache, and let's see. So I like it, but of course the bending effect, it needs to be animated. I don't want this to be always bent like this. So back on the point warp, let's call it bend. We want to set, let's say it will start from 0, right when the core will start to open, so 0 on the maximum value. Then we can start to increase the bending until, let's say, 125. This will reach our maximum value, so 0.5. Alt click to create a keyframe. And then we want to decrease it, let's say until 200. It will be 0 again. So now we have something like this. It will open and it will start to bend, and then it will be straight again right before the closing animation. So now let's just disconnect the transformation and the null. We want it to be at the last of our chain. Also let's realign those nodes and make this green. So now we want to create the geometry container to render our Plexus. Let's call it Plexus RNDR. We want to make it black. Inside, let's take an object merge, go to our core start, and it was out Plexus. Now we want to take a polywash node so we can give it some thickness. Let's say 0.005, and also increase the subdivision to 16. Now let's give it some normals like this, and let's display also the core animation. So we do have our animation. Now we want to hide this Plexus object after the closing animation, so let's take a switch node and we will plug the Plexus as the first input and an empty null as the right one. Let's call this empty. Then let's lay down another null. This will be out Plexus RNDR. And we want this to switch at 225, so just type at frame greater than 224. So display flag on the last null, it will disappear after 225. For good measure, we also could hide it before frame 50, even if we don't see it. So in the switch, we can add end at frame less than 50. So let's hide the core, and as you can see, it disappears also before frame 50.